anytime you have large numbers, scientific notation, of course, can be really useful in actually looking at computations. And so, of course, one place where we see large numbers traditionally are, of course, in populations. There's a lot of people, a lot of things, a lot of bacteria in a petri dish. Let me tell you about something. I've been actually thinking about two countries, country A and country B. Now, I can tell you that the population of country B is about 5.01 times 10 to the fourth people. It's a lot of people. And the population of country A is even bigger because it's approximately 2.3 times 10 cubed times greater than the population of country B. So A is a big country. The challenge is to find the population of country A. And let's see, of course, if we can write our answer in scientific notation. So we know country B. Here's country B. Country B, and this is the population of country B, 5.01 times 10 to the fourth people. And country A is bigger. Look, woo! It is so bigger. It's a big country. And we know that its population is going to be 2.3 times 10 cubed times the population of country B. It's that many more times bigger than country B. And the question is, can we actually find explicitly the population of country A? And the answer, of course, is yes, because we could literally substitute. We know the population of country B is that value. So really this question comes down to just a question about multiplication. So the challenge is to find the population of country A, but it really is just a multiplication challenge, because all we have to do is multiply. The population of country A is what? Well, it's 2.3 times 10 cubed times the population of country B, which we know. So it's 5.01 times 10 to the fourth. So all we have to do is multiply these two numbers that are expressed in scientific notation. And how does one do that? Well, the easiest way I think to do it is just since we're multiplying everything, we can multiply in any order we want. And so I'm going to multiply the 2.3 times the 5.01, and then I'll multiply the power of tens. And then what I'll do is I'll make sure that at the final end of the day, we're going to write it in scientific notation. So let's think about it. So what is the product of 2.3 times 5.01? By the way, you can just estimate to see what the answer should be around. This is around 5, this is around 2, so the answer should be around 10. If you'd actually try it on a calculator, you need a calculator to actually compute this or do it out by longhand. It turns out that the answer is 11.523. And so you can see that's around 10, so we know that's a reasonable answer. Times 10 to what power? I'm taking 10 cubed and multiplying it by 10 to the fourth. What's the rule? We have the same base, so we add the exponents. So we have 3 plus 4, which is 7. So we have this to the 7th power. Now, is this written in scientific notation? Absolutely not. This number here is 11 point something, and I want that to be 1 point something in this case. So what I'd like to do is I'd actually have to pull back a little bit, pull it on back, and bring that decimal over that place. And I want to write this as 1.1523 times 10 to a power. But now what power do I write here to make these two numbers equal? Well, since I actually pulled this over, to get this to be equal, I got to push it back, which means I got to add extra power of 10, which means instead of a 7, I've got to throw in an extra power of 10, making it 8. Why? Because that's actually 10 to the 7th times 10, and that invisible 10 times this gives me the 11 point something. Slides it over back to where it's supposed to be. So that's actually the correct answer, and it's written in scientific notation. Population of country A, which is what I was trying to figure out to begin with, actually equals 1.1523 times 10 to the 8 people. That's a big country.